Hello boys and girls, a very good evening and welcome to the SBI Clerk 2018 exam score booster brought to you by TalentSprint. Well, in this score booster series, we'll be looking at some concept or a particular type of question which can be solved using a smart technique, and that can help you boost your score in the SBI Clerks exam, right? Please note that the SBI Clerks preliminary exam is tentatively scheduled for March or April 2018 as per the recent notification that has been released. So we have about 1 to 1.5 months left for the exam, assuming that it will happen earliest in the mid of March, right? And yes, the last date to apply is 10th of February. So if you guys have not applied for the exam already, please make sure that you do that as early as possible, as soon as possible, and get started with your preparation. Okay, now I think since this is the early days of your preparation, the only advice I would like to give you all is to start your preparation right away without delaying anymore, right? Because the early you start, the better are your chances of selection. Okay, there's no shortcut to success. The more you practice, the easier it gets. So keep practicing as much as you can on a daily basis. Okay, and yes, these score booster sessions that we have for you will definitely help you enhance your preparation and boost your confidence before you walk into the examination center. Okay, now in the session today, which is the SBI Clerks score booster number 1, we'll be looking at something very important for the numerical ability section. Now this is a part of speed math, right? You know that topics like number series or for that matter simplifications and approximations carry a high weightage in the SBI Clerks examination, right? We had seen in our initial discussion that about 15 to 20 questions are from these topics alone, right? Now for you to be able to score more in this section, numerical ability section, you have to be very quick in your calculations. You cannot be just putting pen on paper for everything that you have to do. Okay, so I think in the first few score boosters that we'll discuss, we'll look at some important techniques or speed math techniques actually, which will help you do these calculations faster. So in the session today, which is SBI Clerks score booster 1, let's look at how to find out square of a given number without putting pen on paper. Now this is very important. How do you get square of a number? How do you find out the square of a number, or how do you square a number without doing any paperwork? Now many of you may already know some or the other technique to find out a square, but for many others this is the first time, right? So I request all of you to just hold on and learn this technique that I have for you. Again, I do not suggest that this is the technique that all of you have to follow, right? Because speed maths is one area where you have to be comfortable in what you're doing. So if you're not really comfortable with this method, you can follow the other methods which are available, right? But I would suggest this one because personally I find it to be very generic. It can be applied for any given number without any conditions attached to it, and yes, it's easy also. It's really easy to apply. It just takes about 15-20 minutes of practice to get a good grip on this. Okay, so without wasting any more time, let's look at the SBI Clerks score booster 1, where we'll look at how to find out square of a given number. Now one prerequisite that it has is you should know squares up to 30. You should know what are the squares up to 30. For example, 18 squared. You should know what 18 squared is. 15 squared, 225, right? 18 squared, for that matter, 324, right? Or 25 squared, 625, right? 30 squared, 900, 5 squared, 25, 7 squared, 49. I'm sure all of you know these numbers already, but if you don't, then make sure that you learn up to 30 squares by heart so that you can use this technique effectively. Now what we'll discuss in the next 10 or 15 minutes is how to find out squares of numbers beyond 30. Right? How to find out squares of numbers beyond 30. Like you will find many questions under simplifications where you'll have to find out, let's say 57 squared or 86 squared or sometimes 142 squared, right? Or let's say even if you need to find out what is 869 squared, you can apply this technique. You can apply this technique and get the square in about 4 to 5 seconds maximum. Okay, so let me share my screen and explain you how to find out square of a number which is more than 30. Okay, so here we go. Now let's take some examples to understand this directly. Okay, square, how to find out square of a number. Like for example, let's say you got to find out 61 squared. Right, 61 square of a number. Now, you will not be getting a question as 61 square in the exam, right? This will not be a standalone question, but finding out 61 square will be required to answer some other question, right? It can be a part of some other simplification based question or some other arithmetic aptitude based question. Okay, so how do you get 61 square? Now, I am not asking you to learn these squares by heart. All you have to know is 1 to 30 squares. Right, learn 1 to 30 squares by heart. You should know this. Now, what do you do? The idea is to break 61 as a plus b. 61 is one number given to you. You have to break it as a plus b and then expand it. Now, I'm sure the first thing that strikes to most of us is taking it as 60 plus 1 whole squared. So let's try and do that. Right, expand using the formula. So it will be 60 squared plus 2 into 60 into 1 plus 1 squared. Looks easy, right? 60 plus 1 the whole square. So a squared plus 2ab plus b squared. Now 60 squared is 3600, right? 6 squared is 36. So 60 squared 3600. 1 squared is 1 anyway. So 2 squares have to be used here. And then this product has to be done. 2 into 60 into 1. 2 times 60 is 120. 120 into 1 is 120. So 3600 plus 120 plus 1. Now sum it up. What happens? 3600 plus 120 is 3720 plus 1, 3721. So yes, 61 squared, which is 60 plus 1 is 3721. But then is this the best way to do it? Well, not really. Here it may look to be easy, but expanding 61 as 60 plus 1 is not the ideal way of doing it. Like for example, let's say I have to find out 76 squared. Let's take another example, 76 squared. How do you do 76 squared? Maybe you will say 70 plus 6. 70 plus 6. Try this now. 70 squared plus 2 into 70 into 6 plus 6 squared. Right? 76. 70 plus 6 whole squared. So 70 squared plus 2 into 70 into 6 plus 6 squared. A squared plus 2ab plus b squared. 70 squared 4900. Yes, very easy. 6 squared 36. Easy. What takes time here is the product 2ab. You see 2 into 70 into 6. This would need some time. Again, not a very complex calculation. I am sure you can do it without putting pen on paper, but it takes a little bit of time, a couple of seconds for you to evaluate this, right? 2 into 70 is 140. 140 into 6 will be 840, right? Or 2 into 6 is 12. 12 into 70. See, forget about 70. Take it as 7. 2 into 7 into 6. We can multiply by 10 later. 2 into 7, 14. 14 into 6 is 84. So 84 into 10, 840. Or 2 into 6, 12. 12 into 7, 84, then into 10, 840. So basically the product is 840. And now sum it up. 4,900 plus 840 is 5,740. See, you should be able to add these numbers. I mean, even if that cannot be done, then it becomes complex. So 4,900 plus 840 is 4,900 plus 840 is 5,740. 5,740 plus 36 is 5,776. So result is 5,776. You've got the answer. 70 plus 6 whole squared. 76 squared is 5776. But again, not the best way to get the answer in my view. And I think the only reason for that is the product that we have to do, 2ab. In the first case, it was easy, but in the second case, it has gotten a little complex. Similarly, if you have to do 89, 2 into 80 into 9 will take a little bit of time. So what can be done so that we avoid this product? See, 70 square, 6 square are readily available. 60 square, 1 square are all readily available. What is not readily available is 2ab part. So let's try and do something which can make the 2ab part almost always readily available. How do we do? Simple. The technique is take the base as 50. Consider the base to be 50, which means in the expansion of a plus b or a minus b the whole square, try to fix a as 50. Life will become really very simple. Let's fix a as 50. And b can be b. B can be the other part of the number which will make it a plus b. So a plus b basically has to be expanded as 50 plus b the whole square. So 50 plus b the whole square. What happens? 50 plus b or 50 minus b? 50 plus or minus b the whole square. So 50 squared plus or minus 2 into 50 into b plus b squared. Now, if you're wondering how is it making our life easy, because here also we have to do 50 squared plus 2 into 50 into b plus b squared, try and look at it. 50 squared, like 60 squared and 70 squared, is 2,500. I mean, this is readily available, not a problem. 2,500. What is the advantage here is the 2ab part. You look at this. Since a is equal to 50, since a is fixed as 50, 2 into 50 becomes 100. So this becomes 100b. And then b squared. So the simple understanding is when I have to expand 50 plus or minus b whole square, all I'll do is 2,500 plus or minus 100 into b. Now it's always easy. 100 into b. Whatever is b, multiply that by 100. Multiply that by 100. Here in our case, in this case, b is 1, right? Multiply 1 by 100. If b is 6, multiply 6 by 100. If b is 7, multiply 7 by 100. So 700 or 800 or whatever that number is, multiply by 100 and then b squared. You're getting it? So two advantages. One is the first term is always fixed. It will always be 2500 because the number is fixed as 50. Here you see it is changing 3600, 4900. Here it is fixed 2500. Second term is also largely fixed 100 times b. 100 times b. Right? And then b squared is b squared anyway. So let's do this for the given numbers now. Like for example, I'll do the same 61 squared, 60 plus 1 whole square. Instead of 60 plus 1, let's take it as 50 plus 11. 50 plus 11 whole square. You understand? Same 61 itself, but instead of taking it as 50 plus 1, we are considering 50 plus 11. So what happens? 50 squared plus 2 into 50 into 11 plus 11 squared. Now understand, 50 squared 2005 is fixed. 11 square anyway, I'll have to calculate 121. I don't really have to worry about 2 into 50 into 11. What is 2 into 50? 100. 100 into 11, 1100. But instead of doing all this, I can simply say that since the term b here is 11, it should be 1100. It is plus 11, so plus 1100. If it is minus 11, it will be minus 1100. So mentally, I can say it is going to be 2500 plus 1100 plus 121. 2500 plus 1100, 3600. 3600 plus 121, 3721. The same answer. Similarly, if I have to do 70 plus 6. Right? 60 plus 1, we have changed it as 50 plus 11. 70 plus 6, we will change it as, see 76 was a number. So instead of taking it as 70 plus 6, let's take it as 50 plus 26. 50 plus 26 whole square. It may look to be complex. It appears to be complex. But then actual result is very simple. 2500 plus 2600. Why is it so? Because b is 26. So it will be 2600 plus 26 square. What is 26 square? 676. 2500 plus 2600 is 5100 plus 676, 5776. That's it. So all you have to do is 100b, this is 2500, add this, and to that you add b square. It becomes easy. Suppose I have to do, let's say 63 squared now. What do I do? See, I am putting pen on paper so that you can understand it. But do it yourself mentally. 63 is not 63. 63 is not 60 plus 3. 63 is not 63, it's not 60 plus 3. It is 50 plus 13. 50 plus 13 means what? 2500. Since it is plus 13 plus 1300 plus 13 squared, 169. So 2500 plus 1300 is 3800 plus 169, 3969. Done. Let's say I want 47 squared. 47 squared. What do you do? 50 minus 3. 50 minus 3. So 2500. Since it is minus 3, it becomes minus 300. See, if it is plus b, you take plus 100 into b. If it is minus b, take minus 100 into b. So minus 300 plus 3 squared. Remember, it was 50 minus 3. So b squared. 3 squared is 9. So 2500 minus 300, 2200. Plus 9, 2209. You're done. Let me come back to the video and explain, take a few more examples. I hope all of you have understood the concept, right? What do we do? Expand the number as 50 plus or minus something. 50 plus or 50 minus something. What is the advantage? The first term is fixed, 2500. It's always 2500. Second term is also fixed. Because it is 50, it will give you 100 into b. So whatever is b, multiply that by 100. Now that's not a calculation. It's readily available, right? b is 13. Do you have to worry about what 13 into 100 will be? 13 into 100, 1300. You know, if it is 13, this has to be 1300. If it is 12, it has to be 1200. If it is 14, it has to be 1400. If it is 9, it has to be 900. Plus or minus, respectively. Last term, b squared. You're able to follow? So let's take a couple of more examples. 57 squared. 50 plus 7. So 2500 plus 700. 3200 plus 7 squared, 49. 3249. As simple as that. Why should I put pen on paper? 57 square is 3249. Let me tell you, if you practice for some time using this technique, it will be as good as you have learnt it by heart. 57 square, you'll be like, okay, 3249 is the answer. You're able to follow. It will take about 2 to 3 seconds at best. It'll just take about 2 to 3 seconds. Very, very useful. Very, very useful. Again, I suggest you practice on this. See, just learning the technique, it's not going to help, right? Learning technique alone is not going to help. You have to have enough, you have to have done enough practice so that you can apply it at the right time, right? Let's say I have to do 71 squared. Why did you write, all of you? 71 squared. Please do not put pen on paper. Don't put pen on paper. Take as much time as you want. Find out 71 square without putting pen on paper. You may go wrong sometimes initially. Don't worry about it. You learn it as you practice. 71 square. Instant reaction will be 70 plus 1. Don't do that. 70 plus 1 will make it complex. 50 plus 21. You're done. The moment you do 50 plus 21, half of the solution is done. In fact, 90% of the solution is done. 71 squared. 71 squared. 50 plus 21. 50 plus 21. So 2500 plus 2100, because it is 21, 2100. How much is it? 2500 plus 2100. 4600. Yes or no? 4600 plus 21 squared, b squared, 21 squared. What is 21 squared? 441. Now don't tell me that I don't know what 21 squared is. You are supposed to learn 1 to 30 squares by heart. I told you, right? 1 to 30 squares should be on your fingertips. 21 squared is 441. So I already have 4600. Add 441. 4600 plus 441 is 5041. Yeah. Suppose I want 38 squared, for example, 38 squared. What is it? Minus 12. Simple. 38 is minus 12. 50 is the base, right? All you have to check is how much more or how much less. What's the distance? 38 means minus 12. See, it will get simpler as you keep practicing. It will get simpler, right? Next time onwards, you will not even say 2500 plus 1200 or minus 1200. You know that 38 means minus 12. So don't even say 2500 minus 1200. It is taking time for you to speak it out, right? Do it here itself. See, when you say something, it takes time. Just think and get the values. Do the calculation mentally, right? So 2500 minus 1200. You're not supposed to say actually. Keep your mouth shut. How much is that? 1300 plus 12 squared, 144. 1300 plus 144, 1444. That's your answer. 1444. I can see a lot of you have responded as 1444. 1444. And I'm hoping all of you did it without putting pen on paper. Yeah. So that's the technique. But then there's a problem. Well, you're all excited. I'm sure you have learned something. You'll practice and you'll get better at it. There is a problem. What's the problem? Try 83 squared. Try 83 squared. What happens? 83 squared. 50 plus 20, 33. 83 is 50 plus 33. Okay, so 2500 plus 33, so plus 3300. No problem, you'll add it. Plus 33 squared. Now here comes the challenge. What is 33 squared? You don't know. And you're not supposed to know, because we have understood that only 1 to 30 squares is the prerequisite. 33 square, I don't know. I don't have to learn it by heart. But then, does it mean that again for calculating 33 square, you will take it as 50 minus 17? No. That's not the right way to do it. Then what do? Just change the base. Here, we have used the base as 50. When you cross 80, when you cross a number, see, understand, up to 80 it is fine. Up to 80, it is 50 plus 30. 79 is 50 plus 29. 77 is 50 plus 27. So up to 80 it is fine. The moment you cross 80, the b value is going to be more than 30. And if it is more than 30, you will not be able to find out what b square is. Or you will not know what b square is instantly. So then what you will have to do? Change the base. Change the base to 100. Understand how it's going to impact the whole solution. And this way keep continuing it. I mean, up to 130 you can use the base as 100. Right? You understand? Up to 80 take the base as 50. From 81 to 130 use the base as 100. In fact, from 70 also you can take the base as 100. Right? Then up to 130 you can use the base as 100. From 131 to 180 use the base as 150. And keep continuing. Keep changing the base. But you should know as the base changes how the whole solution will change. Right? It's not going to remain the same. It will change slightly. So let's look at how it will impact when the base is 100. Okay, sharing my screen again. Let's see how do we do when the base is 100. So let's say we have to find out what did we take? 83 square. 83 squared is equal to what? Now you cannot take it as 50 plus 33 squared like I said, because this is 2500 plus 3300 is fine, plus 33 square. Now here comes the problem. I don't know what 33 square is. This is fine, but I don't know what 33 square is. So this is not the best way of doing it. What do? 83 instead can be taken as 100 minus 17. 100 minus 17 the whole square. 83 can be taken as 100 minus 17. Now this time the base is 100. The base now is 100. Okay. So what do? A minus b whole square. Use that expansion. A minus b whole square. So a square 100 square minus, sorry, a minus b whole square, right? So a square minus 2ab, minus 2 into a into b, 100 into b plus b square. So see, like in the first case when 50 was the base, we had the first term as 50 squared, 2500 fixed. Now the base is 100 squared. 100 squared is what? 10,000. So this is 10,000. This 17 square is 17 square. I mean, we don't have to worry about it. What is 17 square? 17 square, 289, right? So this is 289. Yes or no? Now what do we do with the 2ab part? We know a square, we know a square is 10,000 always. So it is fixed. 10,000 is fixed, b square is fixed. What happens to 2ab? Simple. You see 100 is already there. Why did the previous calculation become easy? Because it was 100 times of something. So it was easy. Now 100 is already there in the product. All we have to do is 2 times of B. 2 into B. So what is 2 into B? 34. Minus 3400. Minus 3400. You have understood? So earlier we used to take minus 1700. Now you'll have to double it. And then take those many hundreds. So if it is minus 17, double. Minus 17 is minus 34 into 100. Minus 3400. So 10,000 minus 3,400. 10,000 minus 3,400 is how much? 6,600. 10,000 minus 3,400 is 6,600 plus 289. 6,689 will be the answer. Sorry, 6,889. 6,600 plus 289. 6,889. Are you able to follow? 10,000 minus 3,400 plus 289. For example, let's say we have to find out, so this is 83 square, done. Let's say we have to find out 121 square. 121 square. What do we do? 121 is 100 plus 21. Don't take it as 120 plus 1 whole square. That's not going to make your life easy. 100 plus 21. So 10,000 is fixed. Plus, since it is 21, double. Why are we doubling? Because the base is 100. You know that when the base is 100, you have to double it. It becomes 2 times of this value, right? 100 is already there. So 21 doubles 42. 4200. Plus or minus? Plus. If it is plus here, plus here. If it is minus here, then take minus here. Plus the last term is 21 square. What is 21 square? 441. Add it now. 10,000 plus 4,200. 14,200 plus 441. 14,641 is the result. You're getting it? Let's say I want 113 square. Very easy. 113 square. 100 plus 13. So 10,000 plus 13 times 2. 26. 100 plus 169. So 10,000 plus 2,600. 12,600 plus 169. 12,769 is the answer. 12,769 is the answer. You're able to follow. 10,000 plus 2,600. 12,600 plus 169. 12,769. Of course, when you look at 14641, there is technique which will give you the answer even faster without using this method, because it is 121 square. But I don't want you to learn all those techniques. This is actually 11 power 4. 121 can be taken as 11 square whole square. It becomes 11 power 4. And there is a technique which can get you 11 power 4 directly. But that technique has limitations. What is the limitation? It is applicable only when the number is 11 power something. 11 square, 11 cube, 11 power 4, 11 power 5, 11 power 6 and so on. Right? Otherwise that technique is not applicable. What we are discussing here is applicable. It's applicable for all the numbers. It's a generic technique. It's generic, right? There is no conditions. There is no star mark. Conditions apply. So some of you may come back and tell me that 121 square can be done even easily. Why 121 square can be taken as 11 power 4? So 14641 or 11 cube 1331. There's a particular pattern it follows. Using that pattern you can always find. Like if you want 11 power 7, you don't have to put pen on paper. You can just read out the number directly. Right? But why? That technique has a strong limitation, and that limitation is the number has to be 11. Otherwise it's not applicable. If the number is 12, the technique fails. If the number is 13, the technique fails. This doesn't fail. Always applicable. And you all know you all know a plus b whole square expansion, a minus b whole square expansion. All you have to do is just practice a little bit. Just practice a little bit. Right? Let us take a few more examples. 117 whole squared. 117 square. What is 117 square? Don't say 110 plus 7 or 120 minus 3. It will make your life complex. 117 square is 100 plus 17. 100 plus 17. 10,000. 17 double. 3,400 plus or minus plus, because it was plus 17, right? So plus 3,400. So 10,000 plus 3,400, 13,400 plus 17 square. What is 17 square? You're supposed to know what is 17 square, right? 1 to 30 squares you have to learn by heart. 17 square is 289. So 13,400 plus 289, 13,689. That's your answer. 13,689. I can see people responding already. Let's take something very complex. Not very complex, but at least that's something that looks to be complex. 127 square. 127 square. Now I'm sure in the first look you'll be like, oh, that's complex. But if you follow this technique, it takes about 3 to 4 seconds. Yeah. It may not take 3 to 4 seconds now. It may take a little longer because you're doing it maybe for the first time. But with practice, 3 to 4 seconds. With half an hour of practice, 3 to 4 seconds. What is the question? 127 square, 10,000, 27 doubles, 5,400, 15,400 plus 27 square, 27,729, 15,400 plus 729, 16,129 is the answer. Because I'm speaking out, it has taken so much of time. When I do it myself, I'll get the answer faster. You understand? It's applicable to you also. When you talk, it takes longer, right? Use it here itself. So 127 will be 10,000 plus 5,400 plus 729. 16,129. I am doing the calculation on the spot. If I can do it, I am sure you guys can also do it. What's the only difference? Practice. I have practiced a lot already. You also have to practice. There's no other way out. Practice is the only shortcut, like I had mentioned in the beginning, right? Practice is the only shortcut. I want 131 square. Now that's not possible. Because 131 square is 100 plus 31 square. 10,000 plus 6,200. I'll get stuck at 31 square. Of course, I know 31 square is 961. That's a different story. I mean, with practice, I've got to know. But then, otherwise, 31 square, you're not expected to know. You're not supposed to know. I mean, you're not expected to know. It's not that you're not supposed to know, but you're not expected to know. So 131 square में fail हो जाएगा. Yes or no? टेक्निक काम नहीं करेगी क्योंकि 31 स्क्वायर हमें नहीं पता. अगर आपको पता हो कि 31 स्क्वायर 961 है, देन आप 100 बेस लेके कंटिन्यू कर सकते हैं, राइट? 10,000, 31 डबल 6,200, 16,200 प्लस 31 स्क्वायर is 961. So 16,200 plus 961 will make it 17,161. As simple as that. But then, if you don't know, what do? If you don't know what is 31 square, change the base as 150. Now, I'm not going to do 150 base for you. You can do it yourself. What do? 150 plus or minus something whole square. 150 square, 22,500. First term is fixed. Okay, I think many of you want me to take the base as 150 also. So, I'll just explain one example using 150 and then you can continue like this. Okay, so let me come back to the screen. Let's take 150 as a base. Let's take 150 as a base. Now, the base is 150. Right, I want to find out, let's say 171 square. 171 square is equal to what? What do? I'll take 150. Understand, it's not rocket science. All of you can do it. That's why I'm explaining the reasoning behind the method also, right? I'm not giving it to you like a technique. To do this, and you'll get the answer. I'm explaining you why this technique works, how this technique works. Right? The formula is not important. What happens behind the formula is important. So expand this now. What happens? It is 150 squared plus or minus 2 into 150 into b plus b squared. Now 150 square 22,500 plus or minus, see 2 into 150 is 300. 300 times b plus b squared. Done. That's the process. So earlier with base 50, the first term is always 2,500. With base 100, the first term is always 10,000. With base 150, the first term is always 22,500. This part you have to learn. Otherwise, there's no way out. When the base was 50, we directly take b into 100. When the base was 100, we doubled b and we took those many hundreds. When the base is 150, you have to triple b. 300 into b, right? Understand? 300 into b means what? It is like, you know, if I have to take one step further, I mean, if I have to explain even in a better way, I will say this is 22,500 plus or minus 3b into 100 plus b squared. So what do you see? Base 50, it is 2,500 comma b into 100. Base 100, it is 10,000 comma 2b into 100. Base 150, it is 22,500 comma 3b into 100, and so on. Dot. Continue. 200, this will become 40,000, this will become 4b into 100. So you see, and again, understand this 100 is what? 50 times of 2, 2 into 50. This was 1 into 50. This is 3 into 50. So first term, you know, it is depending on the base itself, base square. Second term, 2ab part is if it is 1 into 50, 100 into 50. If it is 2 into 50, actually 200 into 50, but 2b into 50. Or let me actually make it even easier for you to remember. If it is 1 into 50, look at this. If it is 1 into 50, take 1b into 50. If it is 2 into 50, sorry, 1b into 100. If it is 2 into 50, take 2b into 100. If it is 3 into 50, take 3b into 50. 3b into 100. If it is 4 into 50, 200, take 4 times of b, then multiply by 100. Yeah, it follows a pattern, no doubt. So 151 is 150 plus 21 whole square. So first term is 22,500 plus, see 150 is 3 into 50, right? So 3 times of 21, 63, 6,300 plus 21 square, 441. I don't know, I think fortunately or unfortunately I've chosen all the numbers so far where 21 was the B part somewhere, right? Here 21 was the B part, earlier also 21 was the B part somewhere, plus 21 or something. Yeah, but anyway, now do this. Now addition you have to do. I can't help you beyond this point. And I mean, if you say I don't know how to add, then God help you. 22,500 plus 6,300, 28,800 plus 441, 29,241. Done. Suppose I want 142 squared. How do you do 142 square? It is 150 minus 8. Remember? Just remember minus 8. What, that is important, right? 150 base is important and minus 8 is important. So since the base is 150, 22,500. Minus 8 into 3, minus 24. Times 100, minus 2400. Plus 8 square, 64. Last term is always b square. Irrespective of plus or minus, it is plus b square always. So 140 to 150 minus 8. 150 means 22,500. Since it is minus 8 and the base is 150, 3 into b. 3 into b is minus 24. Minus 2400 plus 8 square 64. So 22,500 minus 2,400. It becomes 20,100 plus 64. 20,164. That's the answer. 20,164. Yes or no? 20,164. Continue like this. What is that? Suppose somebody says, what is 206 square? Don't panic. 206 is a lot easier than 142. Why? 200 plus 6. 40,000 plus 6 times 4. So 2,400 plus 6 square 36. 42,436 is the answer. I'm doing it on the spot. I'm just reading out whatever I'm doing in my mind, right? You also have to do the same thing. If I can do it, you also can do it. Yes or no? So when 150 is the base, you can take up to 180. See, 150 base plus 30 minus 30. Because we know up to 30 squares, right? That's the idea. If it is 200 the base, up to 230 you can do, plus 30. Because 30 after 231, I mean 231 you will get stuck. 31 square you don't know, right? So that's the point. Yeah. Somebody says, what is 309 square? 309 always reminds me of Virendra Sehwag, right? Remember? Multan ka Sultan. Again, some of you might be like, why do you always have to talk about Virendra Sehwag? My personal favorite, and I think I love his confidence, right? And I think we also should have that confidence when you go for the exam. The best thing to learn from him is that from the first ball to the last ball, he'll maintain that pace. He's at his best from the first ball. He will not take time to settle down. You also should not take any time to settle down in your examination, because your SBI Clerk preliminary examination is very, very restricted in terms of time, right? You just have 20 minutes. Now, if you want settling time, I'll first settle, then only my performance will take to its peak. Then you have screwed up yourself, because 20 minutes mein agar settling time chahiye, to time is over. By the time you settle, time is over for that section. So the moment you see the question, you should attack. You should be in the attacking mode, like what he does, right? Anyway, back to the question. So 309, that's how I went to Virendra Sehwag. So 309 square, is it difficult? Not difficult. 309, 300 is the base. And since 300 is 6 times of 50, I'll have to multiply by 6. 6b into 100. That's the technique. So 309 whole square, 300 plus 9 the whole square. You're able to follow. 309 is 300 plus 9. Now what is 300 square? See, 30 square is 900. 300 square will be 90,000. That's how it, extrapolates, right? So expands, right? So 300 plus 9 whole square. So 300 square, 90,000. Remember that. Then 9 should be taken 6 times, because 300 is 6 times of 50. So 9 into 6, 54, 5,400. 54 into 100, 5,400. Plus 9 squared, 81. So 90,000 plus 5,400 plus 81. 95,481. You're able to follow? It is taking longer because I'm explaining it to you. If I had to do it myself, I would have done it faster. I'm not bragging about my skills. What I'm trying to tell you is, you can do it faster. And if I can do it, you also can do it. You able to follow? 309 the whole square. 95,481 without putting pen on paper. In all about 3 to 4 seconds. 5 seconds at best. All you have to do is practice. So I think with this, I'll close the session here. Thank you so much. I have expanded it by more than 15 minutes already. We are supposed to meet only for 20-25 minutes. But never mind. It's always good to learn more. So we'll connect again at 4 p.m. for the SBI Clerks Score Booster number 2. This was Score Booster number 1, where we have looked at how to find out squares of any number without putting pen on paper, without doing any paperwork. The only prerequisite, the only condition is you should know up to 30 squares. That's it. And yes, you have to do 3 more things actually. Practice, and practice a little more, right? So the more you practice, the easier it gets. Thank you so much once again for joining us. We'll connect again tomorrow at 4 p.m. for the SBI Clerk's Score Booster number 2. And yes, we will also be meeting at 6 p.m. today for our SSC CGL Tier 2 exam refresher. And the topic of discussion will be Quantitative Abilities previous paper. So all those who are appearing for the Tier 2 exam, don't forget to join us at 6 p.m. for the SSC CGL Tier 2 refresher. Okay, the subject is Quantitative Abilities. And yes, don't forget to subscribe to our channel. Take very good care of yourself.